Okay, so get this. We're diving into quantum mechanics today. Specifically, quantum superposition.
Yeah, wild stuff, right?
It's not just some theoretical physics thing, though. This concept could totally revolutionize technology.
Oh, absolutely.
Quantum computers, super sensitive sensors.
All kinds of possibilities. It really makes you think.
It really does. And to help us navigate this, we're looking at this article, Quantum Superposition, Grundlage der Quantenphysik erklärt, by
Yergo Snippet.
Jürgen Sneppet, right?
He lays it all out really well.
So maybe let's just start with the basics. What exactly is quantum superposition?
Okay, so think of it like this.
Okay.
You have a ball. It can be rolling or it can be at rest.
Uh-huh.
Classical physics, right? It can't be doing both at the same time.
Right, right.
Now imagine an electron.
Okay.
In the quantum world, it can be in multiple states at the same time.
What? Like it can be both rolling and at rest.
Kind of. More like it can be here and there at the same time, until we try to measure it, that is.
So it's not just our observation that's limited. It's like the electron itself is in this fuzzy state.
Exactly. It's totally different from how we normally see the world.
Schneeppert talks about the double slit experiment.
Oh yeah, the classic.
Can you maybe unpack that a bit? Like,
Mm.
how does that show us superposition in action?
All right, picture this. You fire a bunch of electrons at a wall with two slits in it.
Okay.
Now, common sense would say they'd go through one slit or the other, right?
Yeah, I guess so.
And you'd see, like, two bands on a screen behind the wall.
Uh-huh.
But that's not what happens. What you actually get is an interference pattern,
In an interference pattern.
as if each electron went through both slits simultaneously. Like it was a wave, not a particle.
Whoa, that's wild. So it's almost like the electron is choosing where to be only when we observe it.
Yeah, that's the thing. That's what we call wave function collapse.
Wave function collapse.
The electron goes from this blurry state of possibilities to a single definite state, just because we looked at it.
And Schneeppert really nails this idea in his article, that there's a fundamental difference between quantum and classical physics.
He does. It's a pretty mind-bending concept.
Totally. But then, is it really our observation that's changing things?
Honestly, it's one of the biggest mysteries in quantum mechanics.
So we're not even sure about that.
Not really, but it seems like observation does play a role in solidifying reality, at least at the quantum level.
Okay, so this whole idea of existing in multiple states at once,
Mm-hmm.
that's where the power of quantum technology comes in, right?
Exactly. It's the key to things like quantum computers.
You mentioned those earlier. How do they work?
Think about the bits in our regular computers, zeros and ones.
Yeah, the basic building block.
Right. Now, quantum computers use qubits.
Qubits.
And because of superposition, these qubits can be both 0 and 1 at the same time.
So they're kind of like those electrons we were talking about.
Exactly. They can be in multiple states at once. This means quantum computers can do a ton of calculations simultaneously, like exploring every possible solution at once.
That's incredible. So instead of going step by step, they're doing everything in parallel.
Exactly. It's a huge game changer.
Schneeppert brings up Shor's algorithm as an example of this.
Yeah, Shor's algorithm. It's a really good example.
What is it exactly?
It's an algorithm that can factor large numbers,
Okay.
but it can do it exponentially faster than any algorithm on a regular computer.
And why is that important?
Well, a lot of our online security is based on the difficulty of factoring large numbers.
So theoretically,
Theoretically, a quantum computer running Shor's algorithm could crack a lot of our encryption.
oh wow. Our online transactions, communications, everything.
Potentially. Yes, it's kind of a double-edged sword.
It's pretty unsettling, but also kind of amazing.
It is, and that's where Schneeppert's insights are so valuable. Understanding these technologies is key to preparing for the future.
Totally. But, I mean, Schneeppert also talks about how quantum superposition could lead to super secure communication, too.
Oh, absolutely. It's like a built-in security system.
How does that work?
It's all about quantum cryptography.
Right?
We can use superposition to create encryption keys that are basically unhackable.
Unhackable.
Because any attempt to intercept the key would change its quantum state
And that would be detectable.
immediately.
Hmm.
Both the sender and receiver would know.
So it's like a tamper-proof seal at the quantum level.
Exactly. Pretty neat, huh?
It is. So we've covered a lot here, from the very basics of superposition to its potential in computing and cryptography.
Yeah, we've just scratched the surface, really. There's so much more to it than just computers, too. Schneeppert talks about quantum sensors and material science, too.
Yeah, that was some seriously cool stuff. It's amazing how one concept can revolutionize so many different fields.
Right. I mean, quantum sensors.
Yeah, those blew my mind a little.
Superposition lets us build sensors that are unbelievably sensitive.
Okay, so like, how sensitive are we talking?
Imagine detecting the tiniest changes in magnetic fields or gravitational fields.
Wow. What would we even use that for? I can't even imagine.
Well, think about medical imaging. We could map brain activity in incredible detail.
Really? No more invasive procedures.
Potentially, yeah. It could transform how we diagnose and treat neurological conditions.
That's huge. What about other fields? Anything outside of medicine?
Oh, tons.
Yeah.
In geophysics, we could use these sensors to map the Earth's interior.
So, like, better earthquake prediction.
Exactly. Or even finding new mineral deposits.
Wow. And what about navigation?
Even GPS could get a major upgrade.
I'm seeing a pattern here. Superposition is kind of a big deal.
It really is. And then there's materials science, too.
Schneeppert talked about quantum simulations for that, right?
Yeah, quantum simulations, they let us analyze molecules in a whole new way.
So instead of mixing chemicals in a lab, we can do it virtually
Exactly. We can test out countless possibilities on a computer.
and design new materials with specific properties.
Exactly. Stronger materials, lighter materials.
Maybe even materials with properties we haven't even thought of yet.
It's totally possible. Schneeppert lays it all out really well in his article.
It's like something straight out of science fiction.
It does feel that way, but it's all based on real science.
It's mind-blowing. But Schneeppert also talks about the challenges, right? Like decoherence.
Yes, decoherence. The big problem with quantum systems.
What is it exactly?
Well, you know how these quantum states, these superpositions, are super delicate.
Yeah, they collapse if you even look at them wrong.
Right. Well, decoherence is when those states collapse because of interactions with the environment.
Oh, so even the slightest disturbance messes things up.
Basically, it's like trying to balance a pencil on its tip.
One tiny vibration and it's all over.
Exactly. And that makes building practical quantum computers really tough.
So what do they do about it?
They try to isolate the quantum computers as much as possible.
Like keep them in a vacuum?
Pretty much. And super cold temperatures, too. Close to absolute zero.
Wow. It sounds incredibly difficult.
It is. But the potential rewards are so big that people are willing to invest heavily.
And they are, right. There's a lot of research and development happening in this field.
Governments, tech companies, universities, everyone's jumping on board.
It's clear that Schneeppert is optimistic about the future of quantum technology.
He definitely is. But he's also careful to emphasize that we need to understand the science behind it.
Not just get carried away with the potential applications.
Exactly. We need to know how it works, not just what it can do.
Because that understanding will help us use it responsibly.
Precisely. It's a powerful technology, and we need to approach it with caution and care.
This whole conversation has really opened my eyes to the depth of quantum mechanics.
It's not just about futuristic technology. It's about understanding reality itself.
Like the very fabric of the universe.
Exactly. And who knows what other discoveries are waiting for us out there.
It's a pretty exciting time to be alive, wouldn't you say?
Absolutely. It feels like we're on the cusp of a whole new era of scientific discovery.
It's amazing, right? This tiny concept, quantum superposition.
Yeah.
It's governing the universe at the subatomic level.
Yeah.
And it could help us solve some of our biggest problems.
It's pretty wild when you think about it.
I mean, that's like everything's connected, you know?
Definitely, from the smallest particles to the whole universe.
And Yurigo Schneeppert really gets that.
He does.
He connects the science to the real world.
Yeah, he doesn't just throw equations at you.
Right. So for our listeners, maybe we could just sum up the key takeaways about quantum superposition. Like, why should they care about this?
Sure. I think the biggest thing is that superposition throws our whole classical understanding of reality out the window.
Yeah.
Things can be in multiple states at once until we measure them.
Right.
And then it all collapses into one outcome.
That's just mind-blowing.
It is. And it's the foundation for all these incredible quantum technology.
Like quantum computers and those super-sensitive sensors.
Exactly. And secure communication. It's all connected to superposition.
It's a reminder that we still have so much to learn about the universe. Like, the rules are totally different at the quantum level.
Yeah. It's a whole different ballgame down there.
It's humbling, but also pretty exciting.
Definitely. Who knows what other crazy discoveries are out there?
Maybe even weirder than superposition.
Yeah.
Before we wrap up, though, I wanted to touch on something we've been dancing around. The ethical implications of all this.
Oh, yeah, for sure.
These quantum technologies could have a huge impact on society, right?
Absolutely. For better or worse.
So we need to be having these conversations now.
Definitely. While these technologies are still developing,
Things like equitable access, responsible development.
making sure this tech doesn't get misused.
Schneppet really nails it when he says understanding superposition.
Yeah.
It's not just about understanding science.
Right.
It's about understanding reality itself.
And with that comes responsibility.
Absolutely. This deep dive has given us a lot to think about.
It has. The science is amazing, but the societal implications are huge too.
Huge. Well, thanks for taking this journey with us. And to our listeners, thanks for tuning in to this deep dive into quantum superposition. Until next time, keep exploring, keep those minds open, and stay curious about the universe.